Good morning, children. Once again, welcome back to the online classroom of Sri Gokulam Public School, Guruvayur. I am Jaypriya, your computer science faculty. See, children, in our last class, we were discussing about how to convert a decimal number into binary, octal, and hexadecimal. Today, let's discuss how to convert a binary to octal, hexadecimal and decimal, and also how to convert hexadecimal into decimal, binary and octal number system. Okay, see children, first we can convert a binary number into decimal number. Clear? See, here we have one example. See, 11011. Okay, 11011 base 2. Base 2 means binary. Need to convert into base 10. Okay, see children, to convert a binary number into decimal number, multiply each digits with the powers of 2. Clear? So you can start to write from leftmost bit to rightmost. Okay, from left to right. So here, this one you can multiply by 2 raised to 0, then 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. Okay, so what is 2 raised to 4? 2 to the power 4 is equal to 16. So, when you multiply any number by 1, the answer will be the number itself. Okay, so 1 into 2 raised to 4 is equal to 16. So, you can write 16 plus 1 into 2 cube. 2 cube is equal to 2 into 2 into 2. That is equal to 8. 16 plus 8. Plus 0 into 2 square. When you multiply any number by 0, the answer will be 0. So, no need to do these steps. Okay, because it is multiplied by 0, that is 0. Then 2 raised to 1. If you want, you can write 0 is here. Okay. Then 2 raised to 1 is equal to 2. Then 2 raised to 0 equal to 1. Okay. Then 16 plus 8. 24, 24 plus 2, 26 plus 1, 27. Okay, so this is equal to 27. So, the decimal representation for the number 11011 is equal to 27. Clear? Okay, this is one method of conversion. Then one more method is that one is called double method. Okay, double method that I will explain. Okay, let's do the same question. 11011. Okay, so to convert this binary number into decimal by using double method, first you can write the number. Okay, so here this one is the least significant digit and this one is the most significant digit. So, first copy LSD, that is least significant digit. So, write this one LSD. Okay, this one you can write here. Clear? Then you can multiply this number by 2 and add next digit. This is next digit. Okay, so multiply 2 into this one. 1 plus next digit 1. That is equal to 2 into 1, 2. 2 plus 1, 3. So, first one is 1. Okay, first bit is 1. The next digit is 3. Then multiply this 3 by 2 and add next bit. Okay, that is this 3 you can multiply by 2. 2 into 3 plus next digit 0. That is equal to 2 into 3, 6. 6 plus 0, 6. Okay, then multiply this 6 by 2. That is 2 into 6 plus next digit 1. That is equal to 2 into 6, 12. 12 plus 1, 12 plus 1, 13. Okay. Then our next step, multiply this 13 by 2. So, 2 into 13 plus next digit 1. into 13, 26. 26 plus 1, 27. So this is the decimal representation for the number 11011. Clear? So to convert a binary number into a decimal number, either you can do repeated division or you can do double method. Clear? Okay, both ways you will get the same number. See, now we discuss the same question for repeated division and double method, and both ways we get the same answer 27. See, don't forget to write the base 10. This is the base 10. Okay, next one is binary to octal conversion. See children, binary to octal conversion is a very easy process. But we have to study the binary representation of octal digits 0 to 7. Okay, here I am giving the octal representation, the binary representation for the octal number 0 to 7. That is, the octal 0 is represented as 0, 0, 0. Octal 1, 0, 0, 1. 2, 0, 1, 0. 3, 0, 1, 1. 4, 1, 0, 0. 5, 1, 0, 1, 6, 1, 1, 0 and 7, 1, 1, 1. So children, you should by heart the binary representation for the octal numbers. Should by heart. Okay. See, otherwise you can't convert a binary number into an octal number. Clear? See children, here we have one question, 1, 0, 0. 1, 1, 1, 0, 1, 0. Okay, this one need to convert into octal number. So now let's check how to convert this number into octal number. So to convert a binary number into an octal number system, first you can group these binary digits into group of 3 digits. Okay, that is, you can group from left to right. So first here 3 digit. This one, then put a comma here, again, next 3, again, next 3. Okay, so here 1, 0, 0. Okay, first MSD is 1, 0, 0. So 1, 0, 0 is represented as 4. That 4 you can write here. Then 1, 1, 1. Binary representation 1 represent octal number 7. That you can write here. Okay, then 0, 1, 0, 0, 1, 0 is the octal number 2. So this is the octal representation for the binary number 1, 0, 0, 1, 1, 1, 0, 1, 0. Clear? One more example. 1, 0, 1, 0, 1, 0, 1, 1. Okay, see here, first you can group these 3 digits. Then group these 3 digits. So the last group only 2 digits. See, in that case you can add. See, the last group does not have 3 digits. In that case you can add either 1 0 or 2 0 to make it as a group of 3 digits. Okay, so here you can add 1 more 0 to fill out a group of 3 digits. Okay, then first one 0 1 0. What is the octal representation for 0, 1, 0? 2. So write 2 is here. Next 1, 0, 1, 1, 0, 1 means 5. Then write 5 is here. Then 0, 1, 1, 0, 1, 1, 3. So write 3 is here. This is the octal representation for the number 1, 0, 1, 0, 1, 0, 1, 1. Clear? It's a very simple process. Next one, binary to hexadecimal. Binary to hexadecimal. In that system also you need to study the hexadecimal representation of a binary number or the binary representation of a hexadecimal number. Okay. See children, here I am giving the binary representation of hexadecimal numbers 0 to 9 and 8 to yeah. See here. First 0 means 0 0 0 0. See children, in octal number system, we group the binary numbers as a group of 3 digits, but in hexadecimal, we need to group it as a group of 4 digits. Okay, in hexadecimal, 4 digit group and octal number 3 digit group. Okay, that's why here 0 is represented as 4 digits, that is 0, 0, 0, 0. Okay, then 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, then 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1 for hexadecimal number 9. Then 9 after A. A is represented as 1, 0, 1, 0, B 1, 0, 1, 1, C 1, 1, 0, 0, D 1, 1, 0, 1, E 1, 1, 1, 0 and F 1, 1, 1, 1. Okay, this is the binary representation for the numbers 0 to 9 and A to F. Okay, now let's do one example. Okay, binary to hexadecimal conversion. Here the question is 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0. Okay, this is the question. So first you can group it as a group of 4 digits. Okay, start from left to right. So first 1, 2, 3, 4. Okay, this one you can group, put a comma here. Then 1, 2, 3, 4. Put a comma. Then 1, 2, 3, 4. Clear? Then here first group is 1, 0, 1, 1. 1, 0, 1, 1. See 1, 0, 1, 1 is B. So you can write B. Next 1, 0, 1, 1. Again 1, 0, 1, 1. That is B. Then 1, 1, 0, 0. 1, 1, 0, 0 is C. So this is the hexadecimal representation for the binary. This one. Clear? This is very easy process to convert a binary number into hexadecimal. Clear? One more example. See the question. Okay. So first group these numbers. Here this is the first group and this is the second group. In third group only 3 digits. So to make it as a 4 digit group, you can add 1 zeros here. Okay. So here 0, 1, 0, 1. 0, 1, 0, 1 is 5. See 0, 1, 0, 1 is 5. So you can write 5 is here. Then 0, 1, 1, 0. See 0, 1, 1, 0 is the number 6. So write 6. Then 1, 0, 1, 0. What is 1, 0, 1, 0? A. So you can write A is here. So this is the hexadecimal representation for the number, this one. Clear? It's a very easy topic. Okay, but remember one thing, you have to by heart the binary representation of octal and hexadecimal numbers. It is compulsory. Okay, otherwise you can't convert these numbers into hexadecimal and octal number. Clear? Now I hope you all have understood how to convert binary number into octal, decimal and hexadecimal. Okay, on our next section I will explain how to convert an octal number into binary, decimal and hexadecimal. Okay, see you again. Till then, take care. Bye.